Good morning, everybody. Thanks for joining this session. I have to tell you that I'm pretty excited because it's my very first Cisco Live, and this is gonna be a great day for industrial wireless because today we are launching 2 new amazing products with amazing capabilities, and I'm so happy to be finally able to talk about them during this session. I'm Alice Mazzini. I'm product manager in industrial wireless team, and I'm really, really happy to have such a lovely audience here today interested in discussing reliability in industrial wireless networks. Before we get started, some housekeeping stuff. If you have any problem hearing me, there are some headsets on that table, so please feel free to reach out to the guy at the end of the room so you can get your headset and be able to understand the session well. Second, everybody knows that asking questions is really important. Probably I will not be able to take questions during this session, but no worries. There is a mid-speaker session this afternoon, 3:40 p.m. at the Innovation Forum, so feel free to register to this session and join me there. We can discuss about any question, any topic that you want to bring to me. If you are not able to join the mid-speaker session, there's always the Cisco WebEx app that you can use. You can drop your question even during the session or after the session. The WebEx space will be moderated until February 24th, so you can drop the question there. I will be more than happy to reach out to you later. I want to pitch the key message for the session here. Reliability is the key for industrial wireless automation. We have to keep in mind this key message because this is really important, and we will remind that during the session many, many times. To understand why reliability is so important, I will provide you a brief introduction just to set the stage of the discussion. And then we will go through a couple of technology, and we will discuss how Wi-Fi 6 and 6E bring some features and some capabilities to boost reliability in industrial automation. We will discuss about Cisco ultra-reliable wireless backhaul technology, which is a proprietary technology from Cisco dedicated to industrial automation installation, and multipath operation protocol, which is a new feature that you will find in the new products from Cisco Industrial Wireless that is specifically dedicated to boost reliability. I will show you some MPO results, and we will discuss about some use cases when you can apply this new technology. I will show you the new amazing products that we are launching today and the timeline when you will be able to get those products in your hands. Finally, wrap up and call to action, so some action that I want you to do when you will leave this room. What you should expect from this session. First, to understand the basics of reliability in industrial wireless networks and why reliability is so important. Then get the improvements that the new technology, the Wi-Fi 6 and 6E, brings for reliability. Understand the principles of the multipath operation protocol technology and how it applies to reliability, and then have an overview of the Cisco products providing ultra-reliable wireless connectivity. So let's get it started. As you see here, all these verticals, brings many different use cases, okay? And all these verticals are really accelerating the process of digitization. And we have more and more assets that needs to be connected to the network. Those assets can be mobile assets. So it's impossible to wire those devices because you cannot wire a device as is on the move. But even if you have a fixed asset, maybe fiber isn't available, or it costs too much, or it's difficult to deploy, it's difficult to maintain. So in all these cases, you need to replace the fiber connectivity with a wireless connectivity, which needs to keep the same level of reliability. So industry really requires a future of better wireless connectivity. So the adoption of the wireless is increasing in the industry, and as it is increasing, we have more and more demanding use cases for wireless to be supported. We have more and more mission-critical applications that we have to support, even simultaneously. And of course, there is more competition for the spectrum because we have more and more assets that needs to be connected, and the spectrum is limited, so the competition is increasing. But what really makes a wireless connectivity better than the other, better than the previous one? We have identified 4 pillars for reliability. Reliability is at the basis of all the industrial protocols. And to have reliability in your wireless connectivity, for sure you need to have low packet error rate. Everybody knows that in industrial automation, even a single glitch in the communication can jeopardize the entire OT process, which means that we are losing money. And the process stops, we are losing money, we are losing time. So it's really, really important to have low packet error rate. Second, low and even more important, deterministic latency. Industrial protocols do not tolerate high latency. Industrial protocols do not tolerate high variance in the latency. The latency needs to be as much predictable as possible to have a really reliable connectivity. Third, interference. The higher the interference we have, the higher the problems we have, because of course this will increase the packet error rate, this will increase the latency in the network. So we need to have devices and we need to have an infrastructure that is capable to manage and to mitigate the interference. And fourth, last but not least, fast roaming. We are more and more mobile assets that needs to be connected to the network. So fast roaming is important because it is related also to the latency, it is related to the packet error rate. As I told you before, a single glitch in the communication can jeopardize the entire OT process. So when you have an asset that is moving from an access point to the other, if there is a disconnection, this means that we have packet error rate, this means that we have latency, and this is not tolerated by our application. There are many technologies that can provide you reliability in industrial networks. There's no one technology for all. Probably in many different installations, in many different projects, you might have a combination of those technologies. And the choice of the technology really depends on the requirements. It depends on the service level agreement that you have. It depends on the way that you want to manage your network, that you want to control your network. So we have identified the 3 main technologies that are capable to provide you reliability in industrial automation. I will not focus on private 5G, so this is not a topic of this session, but I invite you to register to the breakout session dedicated to private 5G if you want to have more information about that. I will mainly focus on Wi-Fi 6, 6E, and on the Cisco ultra-reliable wireless backhaul technology. So let's start with Wi-Fi 6 and 6E and focus on the features that are boosting reliability. First, the introduction of the orthogonal frequency division multiple access. This is really important, and I want to explain you why. And why it's different from the OFDM, which is instead supported up to the Wi-Fi 5 standard. We can use an analogy, okay? So let's think about the color columns that you see in the OFDM scheme as tracks. Every single track can load just one single user cargo. So at any given time, you have one track loading one single cargo. Instead, with the OFDMA, every single track can load more than one user cargo. And the resource is divided, so the frequency allocation is divided into resource units, and each user is assigned with a number of resource units That depends on the type of traffic, it depends on the quality of service, it depends on the packet size. So at any given time, the access point is capable to talk with many different users. So in this way, it's possible to deliver simultaneously more information related to different users instead of having just one single user communicating with the access point. And as you can imagine, this increase efficiency because increase the way we use the airtime and reduce the latency. We are capable to deliver more information related to different users at the same time. Second, the game changer in the spectrum availability is the 6E part of the standard. As I told you, interference robustness is something that we have to deal with in industrial networks. And thanks to the 6E part of the spectrum, we have 500 megahertz more spectrum that we can use, from 5945 up to 6425, which means pretty much 20 megahertz channel more. And this occurs, we have more space where we can live, so we have less interference, and we are able to support higher density of clients, or we can use those channels to improve the throughput. So if we have applications that are demanding in terms of throughput, we can use those channels to expand our capabilities and to provide higher throughput. In Europe, only low-power devices are allowed. So, which means only indoor applications are supported in Europe. But in the rest of the world, there are many other countries that are allowed to use the 6E part of the spectrum, even in outdoor. And this means that also standard power devices are allowed. Standard power devices are all the IP67 devices with external antennas. Instead, in the low power indoor devices are devices that are not supposed to be installed in outdoor or harvest environments. But in all these countries, if you want to use this part of the spectrum, you have to deal with the AFC. What's AFC? It's automated frequency coordination. As many of you might know, in the 6 gigahertz spectrum, there are incumbents working that have paid license to use this spectrum. And all those incumbents, especially are telcos, utilities that are doing their own PTP communication on this part of the spectrum. Those incumbents need to be protected. So if you want to use this frequency in outdoor, you have to communicate to an AFC system operator. So the access point has every 24 hours has to communicate its position to the AFC system operator, saying, hey, I'm here, those are my coordinates, XYZ, please tell me which channels I can use and which transmission power I can use. So the database responds to the access point, say, okay, in your location, you are allowed to use these frequencies with this transmission power. And if the access point loses the connectivity with the AFC database, it has to immediately stop using these frequencies and has to move to a different frequency like the 5 gigahertz that is totally open. This is a picture showing you the frequency allocation and in the many different countries all over the world where Wi-Fi 6 is available. Here you see all the orange countries like US are adopting also the standard power devices, meaning 6E is available also in outdoor, and they have opened up to 1200 megahertz spectrum more, because they are supporting from 5925 to 7125. There's a lot of spectrum more, so you can immediately understand how this is a benefit for the industrial automation, because you have really 1200 more megahertz of spectrum. In Europe, we have only, let's say, 500 megahertz more, but this is good enough to expand our capabilities and to be able to support higher throughput and higher density. This is what the standard brings, but what Cisco brings in the new Wi-Fi 6 and 6E products to boost reliability in industrial automation. First, the Clean Air Pro. If you are familiar with Cisco Wi-Fi, you might know the Clean Air. Clean Air is a machine learning, artificial intelligence mechanism to better manage interference. And with the Clean Air, you are able to, the access point is able to tag the interference signals, to locate them, to map them on a map, and to get more information. And this artificial intelligence is capable to elaborate all this information and to take actions to mitigate the effect of the interference. With Clean Air Pro, we are just expanding those capabilities to the 6E part of the spectrum. Many, not all, the access point implementing the Wi-Fi 6 technology have also scanning radio, and this scanning radio is absolutely important to scan the spectrum, to better understand, to better characterize the interference, and also is used to improve the frequency switch off during the DFS event. So if we are not working in the 6C part of the spectrum, but we are still working in the DFS bands, the Clean Air Pro can help you to mitigate the switch off effect when the DFS event happens. Second, the fast roaming. Fast roaming is one of the pillars that I told you at the beginning of the presentation. And the industrial wireless products in Cisco are capable to support fast roaming for the mobility use case, of course. So this is what is new for the Wi-Fi 6 and 6E. Let's move now to the Cisco ultra-reliable wireless backhaul technology. I don't know how many of you are already familiar with this technology. If any, please raise your hand so I can better understand if I have to recap a little bit. Okay, 1, 2, 3, 4, 5. Okay, good. So no worries for the other. Let me quickly summarize what Cisco ultra-reliable wireless backhaul technology is. Maybe some of you might know them as fluid mesh, because CURB, let me call it CURB, is a technology coming from an acquisition that happened 2 years ago. The company that has been acquired by Cisco is Fluid Mesh. And the importance of this technology is that it's really capable to provide reliable connectivity for assets on the move. Cisco ultra-reliable wireless backhaul technology pretty much provides the same capabilities as private 5G in the ultra-low latency communication profile, if you are a little bit familiar with the 5G technology. And it's a proven technology, has been tested, has been deployed in hundreds of projects all over the world, and is capable, instead, comparing with the ultra-low latency communication profile of the 5G, is also capable to provide high throughput. So keeping the same level of reliability, low latency, low packet error rate, seamless roaming, even when you are delivering very high throughput. How does it work? It relays on the Wi-Fi standard chipset. So it relays on the 802.11 chipset. So the benefit is that it aligns with the Wi-Fi evolution. So whenever there is an evolution in the Wi-Fi standard, the CURB technology can get benefit from that. What happens, apart from the physical layer, on top of the physical layer? CURB is an overlay technology. So it works on the data layer, okay? And you can think about CURB as a virtual switch that you can stretch to reach out to any location, to any asset that you want to connect to your network. It doesn't matter if it is fixed. It doesn't matter if it is on the move. It doesn't matter if it is on the move, it is moving faster. So you can use this technology to really provide a backhauling solution, which is different from the access solution, a backhauling solution, and extend your network on a layer 2 to every single asset that you want to connect to your infrastructure. So what makes CURB reliable? First, the MPLS. The basic of the curb technology is this MPLS over the wireless. So you have the layer, the physical layer that is pretty much standard Wi-Fi. On top, there is this MPLS over the wireless that is the one that provides you really the low latency capability. We keep the latency of the communication in the single-digit millisecond. So it really is capable to support all the industrial applications. It's capable to support also high-speed mobility with 0 milliseconds handoff. So the access point and the device, that is on the move does not lose the connectivity with the access point when it moves from one access point to the other. It's always connected. So there is this 0 milliseconds handoff and the seamless roaming that is extremely important to support mission-critical application. And third, the ultra-fast failover. There is a feature in Curve named Titan. Titan works pretty good when you have a failure in your network, and the network is capable to recover in less than 500 milliseconds. But what makes Cisco ultra-reliable wireless backhaul ultra-reliable? And this is the news that we are introducing, the new capability that we are introducing in the new products, which is the multipath operation protocol. This is a new patented technology from Cisco. It only works on Curve, meaning it doesn't work on the standard Wi-Fi, so it requires to run the Curve software stack on the products and allows the device on a vehicle to duplicate the high priority packets over up to 8 different paths. So at any given time, if there is the primary path is, for example, interfered, or if it is affected by an obstacle, so is unreliable, there's always a secondary path that the device can leverage on to deliver the information to the access point. MPO takes the advantage of the diversity because you have such many different paths that you can use, which means that you can take advantage of time diversity because every single path reaches the destination at different times. And this way you can mitigate the fading effect. And you can mitigate also the medium contention because all the different paths are arriving at the access point in different times. You can take advantage of spatial diversity. Different paths means that they have really different journey to reach out to the destination. And this helps you to mitigate the obstacle effect, to mitigate the blockages. And third, the frequency diversity. All these different paths can work on different frequencies. So if there is a frequency that is interfere, you can leverage on a different frequency to deliver the information to the access point. How MPO works. There is a duplication and a deduplication mechanism that comes into the play. Just to make it simple, let's think about 2 paths, the primary path and the secondary path. The device duplicates the packet. It numbers the packets in a sequence and is sent out over these 2 paths. Maybe along the journey, there is a packet loss. So we lose 1 packet out of 3. On the other side, there is an application server. And for the ones that are familiar with the Curve technology, not so many, but some of you are, the application server is the mesh point in the Curve network. And the application server is capable to collect the information, collect all the packets, discard the duplicates packets, reorder the out-of-sequence packets, and to recombine all the packets to get the original information. Those are the capabilities that are required by the duplication and the duplication algorithm. First, it needs to be efficient because we had to avoid additional packet delay due to buffering. We cannot improve reliability and increase too much the latency, because otherwise we are boosting one of the reliability aspects we have, but we are decreasing the goodness of the other one. Second, has to be able to manage packet loss, has to be able to manage asymmetric path where we have high variability and in the delay. Third, it is to be capable to eliminate the duplicates, to rearrange the out-of-sequence packets, and in an efficient way. It does not have to, it's not only a problem of buffering, it's also a problem of computing capability of the device. So we do not have to use too much resources from computing capabilities to manage this algorithm. There are many different techniques to have duplication and deduplication. The basic one, really the basic one, is no-flow differentiation. So what happens? The traffic is classified based on class of services. All the packets are numbered in sequence, are duplicated, and send it over the wireless to different paths. That's all. Easy, easy. But if we want to improve the efficiency in the resource usage, we need to better differentiate the different flows. And here is where the per-host technique comes into the game. So the traffic is always classified based on class of service. The packets are duplicated, are numbered sequentially, but there is a flow differentiation between the packets based on the source MAC address. So we are creating different flows depending on the source MAC address, and this really helps the application server that is getting the information to recombine in a more efficient way the out-of-sequence packets, to recognize the duplicate packets, because he knows that they belong to the same flow related to the same source MAC address. What's different from PRP? If you are Cisco users, you might know what is PRP. PRP is a redundancy mechanism that allows you to duplicate the traffic to provide more reliability and to have a level of reliability more, let's say. What's different from PRP? There's no need to duplicate the infrastructure. You do not need to duplicate switches, to duplicate routers, to duplicate the access point. Even if you have a single access point which is multi-radio, and this multi-radio can work on different frequency, you can leverage on the two radio interface on the same access point to get this level of redundancy. Second, no specific requirements for switches and routers. As you are familiar with the PRP, you know that the switches need to support PRP. But in this case, there's no need to have any particular switch, any particular routers, because everything happens over the wireless. It only duplicates the high priority packet. This helps us keeping the overall overhead really, really low. And last, it only sends the duplicate packets over the wireless, so we do not have any floating of duplicate packets outside the curb MPLS network. So once we know how MPO works, let's see the results, because I suppose that you are really interested in seeing, okay, this is really good, this is on the paper, tell me why and how this really boosts reliability. We did a test on the field in a Cisco warehouse. This is the map of the warehouse. We pick an AMR, so an autonomous mobile robot. And this AMR had made several different loops around the warehouse. And we did this test, and every run was first with a single radio, so no MPO. And then using MPO, two radios in this case. Each run was for about 1 hour and a half. And during this 1 hour and a half, the device made 20 different loops all around the warehouse. And the warehouse is full of obstacles, is full of iron, is really a hard environment. So it's not a plein air, okay? What happened to the latency? With a single radio, we had a latency of 1 millisecond and 1.3 milliseconds up to almost 1 second. So minimum latency in 1 millisecond, average around less than 5 milliseconds, maximum latency almost 1 second. So the average is 5 milliseconds. It's quite good because it's a Cisco ultra-reliable wireless backhaul technology, so it's supposed to be reliable from the very beginning, even without MPO. But what happened with MPO? The minimum latency is pretty much the same. The average latency is also pretty much the same. Instead of being almost 5 milliseconds, is around 3 milliseconds, okay? But look at the maximum latency. It's 177 milliseconds. So we have drastically reduced the variance in the latency. So we are not going from 1 millisecond to 1 second. We are going from 1 millisecond to 100 milliseconds. And this is extremely important. Remind what I told you at the very beginning, deterministic latency is one of the key points to support reliability and to support industrial wireless protocols. Then we monitor the packet error rate. All these red lines are the packet error rate when we run a single radio. There's pretty much no green lines. It's a reliable technology, so we have low packet error rate even without MPO, 0.26% of packet lost. With MPO, pretty much zero. We lost 5 packets over 109,000 packets, which is pretty much zero packet loss. So now, with these two graphs, you can immediately understand how MPO really boosts your reliability in the network and how Cisco ultra-reliable wireless backhaul technology is really designed to support fixed and mobility application in the industrial space. Use cases. Actually, this technology applies to many different use cases in many multiple vertical markets. For example, manufacturing, the factory floor. How many of you are working in manufacturing? Okay, so it perfectly fits for manufacturing space because you can have this technology on your AGV, on your AMRs, and you know that you need to support Profinet, that you need to support all these industrial protocols that are really, really, really demanding in terms of reliability, low latency, and deterministic latency. But it also applies to train vertical market, so the train-to-ground communication. How many of you are working in train-to-ground? Nobody. Okay. So anyway, train-to-ground communication, we have vital communication like the CBTC, the communication-based train control. So all the autonomous trains. Since almost the end of the 90s, every metro train needs to be automated. There's no driver anymore on the trains. And the communication between the train and the infrastructure needs to be ultra-reliable because it's a matter of safety here. But it also supports the so-called no-vital communication, the onboard Wi-Fi, the security cameras on board of the trains. And these applications are demanding in terms of reliability, but are also demanding in terms of throughput, because all these HD cameras and the hundreds of megabits that the Wi-Fi for passengers requires are really demanding also in terms of capacity. Mining. Here is a matter of worker safety. So we need to be really reliable when we remotely control these gigantic dozers and these gigantic holes working on the mining pit. And ports, I really want to spend just a few words more on ports. How many of you are dealing with ports project? Okay. So it really applies very, very well in port. And in port, we have such a variety of use cases that needs to be supported reliably. The terminal operating system, this is maybe, I don't want to say easy because it is not easy, but comparing with others is probably the easiest one. The autonomous teleremote, all the RTGs, all these cranes that needs to be remotely controlled that are totally autonomous requires an ultra reliable wireless connectivity. And on top of all these use cases, there's also the OCR, the optical character recognition, that requires reliability, but at the same time requires high throughput because you have all these HD cameras that needs to recognize characters on the container, and you cannot miss this information, otherwise your operation will stop. And for the one that work with ports, they know how much every single minute of down in the system really costs a ton of money to the customer. I leave this slide for you. This is one project that we deliver with the Curve technology. There are a lot of information related to this case study. The customer is super happy with the technology. I leave this here just for reference. You can go to cisco.com, search for Malta Freeport Terminal. You will find white paper, use cases, and a lot of information. If you want to know more about that and about many other products, feel free to reach out to me, and I will be more than happy to share more information with you. Then, okay, great, good technology. We know, we tested it, we know it's working, we tested it. Where I can find it. Products. I don't want to talk right now. I will stop for a second. I will let you see this video. I hope this will energize you as it energized me during these days, and then we talk about that later. Okay, this is the new product that we are launching today. It's sexy, right? I think that is really sexy. So this is a new product, and this is really a news for Cisco because it's the very first Cisco product that has been designed to be a client. You can mount it on your AGV, you can mount it on your AMI, you can mount it on every mobile assets that you need to connect reliably to your network. It's very small. Please visit us at the World of Solution. We have few of them so you can touch it. You can see how this is compact, how this is really, really, really designed to be your client for your mission critical application. Together with the IW9165E, we are launching also the IW9165D, which is the small brother of the 9165E. It's pretty much the same radio, but in an IP67 ruggedized enclosure, and is really designed to be your solution of choice for backhauling, fixed backhauling, point to multipoint, whenever you need to extend your connectivity, for example, between buildings or in a parking lot, or whenever you cannot run a fiber and you need something that is easy to install, that is compact, it's pretty much like that. And it has an integrated antenna working on 5 gigahertz and 2 external connectors if you want to use it on another 5 gigahertz radio, or if you allow to use it in 6 gigahertz spectrum. The first one instead is really the big brother of the family, is the IW9167EH. This product has been launched in Cisco Live US last year, is available now, is orderable now. First customer shipment is going to happen next week. So this is the big brother because it has 3 radio, MIMO 4x4. The other 2 products instead are dual radio 2x2. And it also has a 4th radio, which is the scanning radio, which is super useful to support the Clean Air Pro feature that I described at the beginning of the presentation. 9167, 9165E have different flavors. So you can run the product as a standard Wi-Fi. So the 9167EH can act as an access point, as a Wi-Fi 6 or 6E access point, can run as a WGB work with bridge unit, or you can run it as a curb device. Instead, the IW9165D only supports curb. So one single hardware, different flavors, different technology you can use. This is really, really, really flexible choice for your installation. And if you want to start, for example, with this guy, the 9165E, and you already have your Wi-Fi infrastructure and standard Wi-Fi, and you want to protect your investment, and you are not in the position to scrap everything and put the awesome Cisco Ultra Reliable Wireless Backup technology, you can run it as a WGB client. So you can immediately take advantage of the small form factor, take advantage of all the features that I presented at the beginning. And later, maybe, when you are ready to also replace the wayside, so your fixed infrastructure, your set of access point, you can buy, for example, this guy, you can deploy this guy, just set to factory default the unit, boot it again, and say, okay, now I want to run it as a curb unit. That's all. You have done. You don't need to change the hardware. Everything is already there. Next question that I think you have is, okay, when I will be able to get everything? This is the timeline. So 9167 already available. Customer shipping is happening next week, so feel free to go to reach out to your sales representative and ask for more information, prices, and whatever is related to 9167. 9165 will be instead orderable late spring, targeting May. First customer shipment for 9165 in the curb flavor will be August, so late summer, together with MPO. So we are launching the new products with the MPO capability already in there. Instead, for WGB, you need to be a little bit more patient because you have to wait until November to get the first customer shipment for this product. Please visit the IoT space at the World of Solution. I will be there all day long during all the events, so please reach out to me if you want to have more information about this product and many others. So, wrapping up. Takeaways, what we learned in this session. Main message, reliability. Really, reliability is the key for the industrial wireless automation. If you don't have reliability, you are not able to support the industrial protocols in your best way. Wi-Fi 6 and the Wi-Fi 6E technology improves reliability, so are really capable to support the industrial and the mission-critical application. We understood that MPO is a game changer. We really provide a boost, something that nobody else is capable to do, to support the ultra reliability. And we know now that we have products that can really deliver those features to provide you this ultra reliable wireless connectivity. Call to action for you when you leave this room. Please register and come to the Meet the Speaker session. I will be there for you, and I will be super happy to take all your questions and to discuss about all the topics that you want to bring me. Second, I will never stop to say that. Visit World of Solution. We want you there because you can touch the product and we can discuss how to integrate your product in your architectures. Third, I would like to suggest you a session of a colleague of mine. Is happening tomorrow, 8:45 a.m., 1 hour and a half, where when he will tell you how to deploy indoor wireless mobility for industry. For the ones that are working in manufacturing, this is a session for you especially. It's open to everybody, but for manufacturing, this is really super interesting. And DJ Cole, which is the speaker, is an amazing guy. Then, how to say, feedback for us is really important. Feedback is really important also for me. I will go through the surveys of this session one by one. So please, take as much survey as possible of the session. Your feedback is really important. We are looking for any improvement. We want to make you happy. So please take the survey session. And if you complete a minimum of 4 sessions, you will have a souvenir from Cisco Live, which is a nice T-shirt from Cisco Live Amsterdam. And last, continue your education. Visit the showcase, attend the demos, book your one-to-one at the Meet Engineer, attend all the sessions at the DevNet, Capture the Flag, the Working Lab Zone. There are really, there's a ton of content here at Cisco Live. Take advantage of that. This is really a unique occasion for you to learn more about the industry, to learn more about the solution. And if you're not able, as of course it's impossible for you to join all the session, there's always the on-demand library that you can visit at ciscolive.com/on-demand. I think that for today it's all, and thank you.